we'll get started. We left off on Friday. We were talking about object-oriented programming with the S3 object-oriented system, and we briefly talked about creating new methods and generics. And S3, being the ad hoc system that it is, just allows you to create new generic functions simply by saying use method f. So here, if we want to define f as a new function that is a generic function, all we have to do is use method f. Okay? And once again, a generic function is, the advantage of a generic function is that you have one function name that will behave differently based on the different class of object that's provided to the function. So for example, swing would be a generic function or a generic verb that takes on different motions based on whether I give you a bat or an axe or something, okay, or a golf club or something like that, okay? So similarly, if we want to just say print, we can just say print rather than saying print using the specific version of print for this function or for this object class. So all we have to do is just say use method f, and this defines f to be a new generic function. And then to make the specific versions for each class, we say f.a. This is now the method of f that is specific for objects of class A. All right, and so f.a is a function, and all it does is it's going to return the phrase class A. All right, and so if we define an object A of class A and we give it to the function, then that specific version of the function runs, and we say class A. You can also make specific methods for a certain class for functions that already exist. So you can just say mean.a. This is now a specific method for objects of class A for the existing function mean. Okay. The method dispatch. All right, this is a little bit more technical stuff. This is how does the language know how which method to use? It just does use method, and it searches for functions that are named the generic dot the class. Okay, so here if we just write f.default, this is what will get run if no object class is provided. Okay, so here if I say we're giving it an object of class A, it will run the method for class A. Here we're giving it an object of class B and A. So the class could be a vector, which means first search for a method specific for class B, and if you don't find it, then use the method specific for class A. So here the object is just an empty list with class attribute B and A, and so there's no f.b, so it doesn't run that, but it runs f.a, and so that's why it prints out class A. Whereas over here, there's no method for class C, there's no f.c, so it falls back to the default, and it will say run f.default, which is, it's going to print out the character unknown class. And that's what we have here. All right, so there's something called group generics. Make it possible to implement methods for multiple generics with one function, and these are kind of these things. This is just mentioned here for kind of completeness. Don't worry about group generics here, okay? But you can call the functions directly. All right. So, for example, we could say f.default on object of class C, and this is the correct thing. But we could also call the f.a method on the same object, all right? So normally we just do f of c, right? F parentheses c, and we will allow R to figure out which is the appropriate method to dispatch. That's what method dispatch is all about. R will say, what is the object that you gave me? Okay, you gave me this object class. Now it's my job to figure out which method to run. And it will do that. But if we wanted to, we could say, I want to run this specific method. So I could say, run the method f.a, even though the object I gave you is of class C, right? And R will do its best. And in this case, it runs the method for class A, okay? And this is a dangerous practice, but it's possible, right? So sometimes you'll see me, for example, I could create a factor. All right, so G is a factor, but if I wanted to, I could. So normally if I do print G, this will print the appropriate method. It will say G is a factor, and I'm going to print G according to its print method, which is print factors out this way, right? But I could tell R, you know what? I want you to print it using the default print method. And what will this do? It prints the underlying integer, right? Because type of is integer, and we can do as.integer G, and it does this. And so I could explicitly say, you know, print it this way. Okay. Similarly, I could make a data.frame of x is 1 through 3 and y is, 3 through 1. Okay. So this is how the data frame normally prints. Okay. If I did print.default on the data frame, what would it print out? What's the underlying structure for a data frame? A list, right? And so print.default will print out the data frame in list structure. Okay. So, I mean, and I could explicitly call print.data.frame on df, and it will print it as a data frame. Meanwhile, I could create a list. Okay, so L is a list, but I could force it to print as a data frame, and it says I can't do that, and that's because the attributes of L are blank, whereas the attributes of a data frame has row names. So so if I create, if I say L has attributes of L $, row names, row.names. Try it. Maybe I have to specify dimensions too. Okay, maybe you can't do it. So if you try to force the print.data frame, it might not work. You could try to do as.dataframe L, and maybe it works. Okay, so sometimes forcing a specific method onto an object that's not of the correct type will not work out the way you want it to. Okay, so generally this is not a good idea to do this. Print.default will often work most of the time, but not always. All right. Okay. Is that all right? Let's try a little bit of practice here. Maybe I'll make a question. All right, everybody log into the online poll. I know it's your favorite part of the class. All right, here I will do. Okay, let me ask write down the first question. Okay, what will f of k return? All right, how big do I need to make this for you guys in the back to be able to read it? And our choices will be, what is k? K is 2, okay. So it can return an error, it can return 5, it can return 6, it can return k, or that's what we'll say. Okay, but don't the poll is not yet open, okay? Because I haven't actually asked the question yet. Hang on. I gotta log in. Oh, shoot. Okay. Are we DDoSing the site here? All right, are you guys able to see the code? Here, I'll clear out my environment. Try to reason this through rather than typing it out into your computer and figuring this out. All right, this is what we want. Okay, so f is going to be use method f. Right, and then I'm going to define. Hang on, let me log in here. Okay, and then we'll create a quick poll in a moment here, okay? And then I'm going to create a method called f.j. And I'm going to create a method called f.k. And then I'm going to create an object called k with the value 2. And the first time I'm going to write f of k. This is not the question, okay? But I just want you to see what will happen when I run f of k here. This returns an error. It says error in use method f. No applicable method for f applied to object of class C double numeric. Okay, which means here we have the generic function f. We have a method called f.j. We have a method called f.k. But k, what is the class on k? There is no class, right? The class of k is just double numeric. It's neither class j, it's neither class k. So it returns the problem here, okay? All right, this is going to be your first question. Now I'm going to continue on. I'm going to say class of k is this, and then I'm going to run f of k. So your first question is, what will this thing return? And so I'm going to click quick poll, and that should open up here. And your answer choices are, what will f of k return? Let me post. How do I do this? All right. So here are your answer choices, and this is the code that has been written so far. Okay, and again, I know you are armed with your laptops, but rather than trying to just quickly type out the code and get the answer because you're unsure of yourself, just look at. It's an online in-class question. The stakes are super low. All right, it's okay if you get it wrong. Don't.
So you establish f as a function, and then by segmenting it dot class.
Okay, all right, do we get our answers in?
No.
All right, get your answers in, please. Okay, 5 seconds to get your answer in. 4, 3, 2. Did we get our answers in? Okay, all right, let's, whoops. I clicked the wrong button. Okay, I'm gonna close the poll here. All right, the poll is closed. All right, let's take a look at what running this will run, okay? So I do this and it returns back 5, okay? And it also says attribute is J. All right, so what happened here? Oh gosh, this is a method. All right, so so the class of K, if we ask what is the class of K, it's named K, but the class of it is J. So it's going to run the method f.j, which is going to be x plus 3, and so K has a value of 2, so it's going to do 2 plus 3, and it's going to return back 5. All right, is that okay? All right, let's try another one here, okay? I'm going to create a function called f.default. This will return x plus 100, all right? And then I'm creating a method called f.l, which returns x plus 5. And I'm creating an object called L, which is of class K and L. Can we keep track of all of this? This is in your okay, so far you have methods f.j, f.k, f.default, and f.l. And L has the value of 10 with the class KL. Okay, and so now I want to know what is f of L. All right, and let me put up some answers here. What are my choices? Oh, 13, 14, and 15. 13, 14, 15, and let's do 110. Okay, all right, so I'm going to open up another quick poll. Quick poll. Okay, so this is your next question. What is f.l? So you've got f.j is x plus 3, f.k is x plus 4, f.default is x plus 100, and f.l is x plus 5, and L itself is structure 10 class KL.
What do we want? F of K.
Oh, I'm sorry, f of L. Okay, get your answers in. So again, this is R's object-oriented system allowing us to just call the function f on different class types, right? Here I'm just doing very simple examples so you can see exactly what's happening, but this is what powers basically the print function, your mean function, all of those functions that you only need to know like 1 or 2 commands and it works for all of those different object types. Okay, I'm going to go ahead and close the poll in like 5 seconds, so get your answers in.
There was no K.
Okay, f dot L has the value of 10, and we're doing this. Okay, 3, 2, 1. We're going to close the poll. Okay, let's see what you guys picked. Oh wait, no, that's not. I don't know how to do this. Okay, you guys most of you picked C. All right, and let's run f of L, and indeed it returns 14. Okay, because the class of L is K first, so it's going to look up f dot K, right? If I came in and I did remove f dot K, right, and then I ran this, and this is not a question, then it would run the f dot L, because f dot K doesn't exist, right, because I just removed it, I just killed it here, and now it returns 15, because it searches for f dot K, but then it says, hey, that doesn't exist, so then it says, well, f dot L exists, and that's going to be x plus 5, and returns back 15, right? If I call f dot J directly on the item 7, what will this return? We should have questions, huh? But we won't do this, all right? Show mercy. F dot J on 7 is going to run f dot J, so it will return 10. Okay, but if I run f on 7, what will this return? It will run f dot default, because there's no class assigned to this number 7, right? So it's going to run the default, which is x plus 100, and it will, it will return 107. Does that make sense to everybody? Great. Okay, well, thank you for playing today's game of online poll, and stay tuned for more. All right, so I think I posted these examples in CCLE for you to check out. Okay, so that covers what I wanted to say about S3. We're going to just jump into S4, and I probably won't get through all the slides today, but I'm just going to be satisfied with my life and just allow you to kind of read through the stuff on S4 and reference classes at your own time. Or I'll kind of go through a little bit this stuff, a little bit more quickly, okay? Just because, at least in this class, I put less emphasis on the S4 and reference class object-oriented systems. So I think if you know the S3 object-oriented system pretty well, that will get you through most of R, and then there's only a few things, not a few, but the S4 object-oriented system is less critical, okay? And in fact, you could probably get through all of R without knowing, not all of it, but get through quite a bit of R without knowing too much object-oriented stuff. But the S3 is certainly very useful. Okay, so S4 is basically like S3, except it's a lot more formal. So with S3, I could just go on the fly and just say, f is a new function, use method f, and that creates a generic function for f. And then I just say, I want to create a new class of object K or a new class of object J, and R lets me do that. You can't do that with S4. You have to come in ahead of time and say, this is the class, and this is how it's going to work, and so on and so forth, okay? So classes now have formal definitions, which will have their fields and inheritance structures rather than just coming in after the fact and saying class of K is J or something like that, okay? We have to formally define all of this stuff here, okay? And then, and with S3, method dispatch, I guess you answer the online poll, you check out, huh? Rude. The method dispatch can be based on multiple arguments to generic functions. So with S3, the method dispatch is based only on the class, right? So it just says, what's the class of the object? Oh, it's class J. We're going to run this function. It's class K. We're going to run this function. With S4, you can have other arguments to say, like, which method to use, but to be honest, I've never programmed something like this, so don't ask me too many questions about this feature here, okay? And then for extracting the slots, we use the @ sign, which feels really weird because I'm used to using the $sign to pull things out of a list, but for S4 we use the @ sign, okay? But all right, do you need to know this for the test? So, eventually coming up, there's a midterm exam. I would say you need to know S3, but you're not going to be responsible for S4 or the reference class stuff on the test, okay? So as soon as you say that, everyone's like brain turns off for the rest of the lecture. But we will encounter reference class later on in the course when we do some simulation and stuff, and I think it will be useful. So, but it's not going to be on the midterm exam, which already kind of tells you how important I feel this is as a topic, right? But the reference class is definitely useful, and we'll see that later. Okay, all S4 stuff is in the methods package, and you can do library methods whenever you're doing S4. It's always available whenever you start up R. Library methods shows up in your search path. But then sometimes, like in batch mode, I don't know if you guys are familiar with batch mode, but it's kind of the idea that you write these scripts and then without even starting up R, just from the command line, you just say like, run this script, and you can even like put it on a timer or something. And this thing might not be available if you do it in batch mode, but are you guys going to do stuff in batch mode? Maybe. All right. You can always ask R, is it S4? And then that will return true if it's an S4 thing. There's no S4 classes in the base packages, all right? Everything in your base packages have been implemented in S3, okay? But there is, so there's the stats4 package has the function MLE. MLE kind of fits a maximum likelihood estimate for the model, and that returns as an S4 object. And so you can say, is it S4? And it will return yes, yes it is. Okay. The generics, okay? So much like the S3, functions are generic functions, and it would, the n observations function is a S4 generic, meaning you can say n observations as a function for this class object or a different class object, and it will appropriately dispatch the correct method, okay? And so if you say number of observations called on the fit object, which is the MLE, the output of MLE, right? So fit is going to be the output of whatever MLE is, and that's an S4 object. So here we call number of observations, that function on fit, right? And this will dispatch the appropriate n observations method specifically for MLE, right? And you can get that information by asking R for the appropriate method from this call. And it will say that's an S4 method being dispatched there. All right, okay, well, we're just gonna skip through this. Defining classes and creating objects. If you're gonna do it, you have to use the set class function, and you create new objects using new. If you create lists, they're known as slots, and we'll run through this. So here, we're gonna create a class called person. This is a person class, and it takes two, has two fields, the name field and the age field, okay? And so this is this. Then we're gonna set a class employee. Employee inherits from person, so it says contains person. So that makes all employees people. And but if you're an employee, you also have one more field known as your boss, but the boss itself is of class person, okay? And so we define new instances of this class by saying Alice is a new person whose name is Alice and age is 40, and John is a new employee whose name is John, age is 20, and the boss itself is going to be object Alice. Okay, so there's an entire person that fits in there. So that's how this works, and that's that. Okay, and then of course, just seeing the example here, you can always make things much more complicated. But this is kind of the basic thing. One thing you notice is that when we say the name and the age, we are specifying the name data is character data and the age data is numeric data, right? This is not, you didn't have to do any of this stuff in S3. S3 was just like, la-di-da, new classes. And this is, we have to say like, oh, we're gonna get character data. And then if you tried to define a new person and you didn't give it character data here, it's gonna kick back an error and say you can't do that. Okay, and then to extract that, again, you use the @ sign rather than the $sign, and so this always feels very strange to me, but we can, and then, or you can use the slot, which is very similar. Again, it's an interactive programming language, so meaning you can keep adding new lines of code, and R is not going to go back and check to make sure everything you've written in the past functions correctly and things like that when you write a new code, and it'll just try it, and if it works, and if it doesn't, it kicks back with an error, right? Versus a compiled thing, it reads through the entire thing and it makes sure that every single line of code is kind of compatible with everything else when you try to compile it. So you can create a new class or redefine existing classes, and this could be a problem, right? Because you might be able to change something. So here we've got Alice, and then Alice is a person class whose name is Alice and age is 40. We've already defined this. And then later on we're like, oh, you know what? I feel like modifying what it means to be a person. A person has a name and an age and also a location, okay, a city. And then so now we've redefined what it means to be a person, and according to this definition, Alice no longer counts as a person. And so when we say, oh, I want to know about Alice, it says, we have a problem, okay? Alice doesn't have a city, so it doesn't work, right? All right, and then you could create new methods and new generics by doing set generic, okay? So rather than just doing use method, now we're gonna create set generic. Union is now gonna be a generic function for union. And then we say set method, and set method will say, okay, for this version of union, okay, this version of union will apply for the arguments when X is a data frame and Y is a data frame. So we are providing it what class of object needs to come in for the arguments. And this is how we do it. Okay, and so I'll just kind of skip through all of this. And I guess that's it for S4. I know that was really fast. If you get to a point where you're going to start writing your own packages and you want S4, there's lots of resources available. Okay, so this is mostly just to kind of say this other thing exists and it's a lot more formal, and S3 works most of the time. Sometimes you want formality to prevent people from hurting themselves, right? So you set up more rules, and that way they can't break things. But if you expect your users to be well behaved, then S3 can generally cut it most of the time. All right, reference classes. This is an object-oriented system that's implemented kind of using the existing R system, but people said, what if I want the methods to belong to the objects, like in pretty much so many other languages, like in C and Java? You don't say, you don't give it a generic function like swing and say, oh, I'm giving you an object baseball bat, so figure it out. With message passing object-oriented systems, you say, this is a baseball bat. What can you do with a baseball bat? These are the actions that are allowed with baseball bat. With baseball bat, the actions are allowed are swing and carry and, I don't know, what flip, right? And so these are the actions that you can do with a baseball bat, and other verbs or other functions are not allowed. Okay, and you give it a different object, like you have a car or something, and you say these are the methods that are allowed for a car, right? Like start the car, hit the gas, fill the fuel tank, or something. And so in reference class, the methods belong to the objects, not the functions. So you say these are the verbs or the methods that can be done, and those are defined inside the object rather than the function. And then the other kind of big thing that's very different from what we're accustomed to is that the objects are mutable, meaning that normally whenever you change something in R, it creates a copy of it. Okay, whereas over here, if you point to something that's a reference class, it points to the same thing. Okay, and you modify it, then the other things that are kind of looking at that one reference will also be modified as well. Okay, and so this makes it implemented, or it looks a little bit more like Python or Java. And they're actually implemented as special S4 objects wrapped inside an environment. So every time you create a reference class, it's creating its own environment where the objects exist and things happen there. Okay? So if you want to create a new reference class, you say we're going to create, you use the function setReferenceClass, and this is going to be a reference class of class account, okay? And here I'll store this as account, okay? And then if I want to create a new instance of this reference class, I do account $new, okay? So all reference class, as soon as you say we're going to create a reference class, it inherits some methods that belong to kind of your ultra parent reference class, okay? And one of those methods is new, right? And so anytime you want to create a new reference class, you just say, all right, let's create a new thing, $new parentheses, and this will create a new reference class object of class account. That's what we have. Okay, when you, of course, to make it useful, you need to provide the reference class object some fields or values to carry and verbs or methods, okay? So here, we'll start off with just creating a balance. And so if we got an account at the bank, the one field that we're going to keep is going to be balance, all right? And balance will be a numeric object, and so all we're going to say is the account reference class is going to be called account, and inside its list of fields is one value called a balance, all right? So we say A is going to be a new instance of the account where balance is set to 100, and we say what's the balance in A, and it's $100, okay? And we say, all right, I want to change that balance. A $balance is now 200, and R says, all right, A balance is now 200, okay? This is where things are probably different from what we are accustomed to. Now I'm going to say B. We're going to take A and store it into B. Normally in R, whenever you do this, B is a copy of that original A. Okay? And then so you ask, what's the balance in B? And so over here, A currently has a balance of 200. We say B is, pointing to A. And we say, what's the balance in B? That's 200, okay? And now I change the balance in A to 0. I didn't change the balance in B, but if I call what is the balance in B, it has also changed to 0, okay? And that's because B just references A. It's not a copy of A, it's a reference to A. And so, so this kind of stuff with reference classes can get confusing if you're not accustomed to this. This is the kind of the behavior that happens in Python, is that things kind of point to the same thing, they point to the same reference, and so maybe this looks normal to you. But if you're coming strictly from an R background, this kind of thing might weird you out. So if what you want is a copy, you have to use the copy method, okay? So we left off with A having a balance of 0, and then so we say A, make a copy of A and throw that into D. We ask, okay, what's the balance in D? Balance in D is 0. We're going to change the balance in A to 100. So the balance in A is now 100. And then we ask, what's the balance in D? The balance in D is still 0, okay? Because here we created a copy of A and stored that in D, right? So do these two slides make sense of what's happening? Okay. So this is reference classes, right? So we're referencing this environment where the values are stored. All right, you want methods, okay? Again, the methods belong to the classes, the objects themselves, and not the not generic functions. So here we're still going to just deal with our account reference class where the balance is numeric, and then we define two methods. We've got a withdraw method, which is a function, and a deposit method. Okay, the withdraw takes the balance, subtracts off x, and stores that back into balance. You'll notice, and then the deposit is balance, add x, and store that back into balance. Okay, you'll notice for these functions we have super assignment. Okay, and that's because you have to think of the account as this kind of sandbox, okay, this environment, and inside the account there's an object called balance, and also inside that same sandbox are two functions, one called withdraw and one called deposit. And when you execute withdraw, that function, it creates a separate execution environment with the value x, and then it searches for that value balance. So it goes up to the sandbox balance. And so here, if you want to modify the balance in the environment account, you've got to use the super assignment so that it doesn't modify just what's in the execution environment, but it modifies what's in the environment for account. It made sense when it came out of my mouth. I don't know if it made sense when you guys received it. So, so what's happening here is, again, all of this exists inside the environment for the account. And so if you want to modify the balance in the account environment, you have to use super assignment so that it does not modify the balance that exists only in the execution environment. So we use super assignment and we do this, okay? And this will never modify things in the global environment as long as this word balance is something that exists in the fields, right? If you don't have the word balance here, then it will start searching in the keep searching up the scopes. So as long as you've got balance listed here, then it will not modify things in the global environment. Okay, so anyway, we do this, and now we can do this. So we can say we're going to create a new account with a balance of 100. A is that. We run the method deposit 100 into A, and we ask what's the balance, and it says the balance is now 200. Okay. And then if you want to create kind of like other reference classes that inherit from others, you can just say contains this, and then you just modify whatever function you have, and these things also exist. Okay. So I'll just I'll let you guys kind of scroll through these things here, but that kind of covers what I wanted to say about S4 and reference class object-oriented systems. We will encounter reference classes again in a future homework assignment, but other than that, I would say study the S3, and I think that's the most important object-oriented system in R. Okay. All right, we'll end here, and we'll see you guys on Wednesday.